Hello everyone, we are the member of group 38 and today we are going to present our data science project, analysis of Indian mutual funds. So let's brief you with what is mutual funds. And investment programming funded by the shareholders that trades. It's a diversified holding and professionally managed. Type of mutual funds is equality fund, dividend funds and hybrid funds. Problem statement. We are given the data of NAVs, repurchase price and sale price of many different mutual funds for each day from 2006 to 2021. We are supposed to find some insight from the data with the help of which we are shown in hypothesis testing and some predictions. Table of contents. At first we have data extraction, and second data preparation, third data visualization, fourth data statistics, and fifth data prediction task, and sixth is hypothesis testing. Number first, data extraction. We are given the data from Kaggle dataset of Mutual Fund India. The data was around 3 GB of content, more than 5,700 CSV files for particular data sets from date from 2006 to 2021. Each file contains the data from more than 800 different mutual funds. Now there's a lot of data. Therefore, we reduce the data considering the mutual funds from 2016 to 2020 because of the penalty of them were old and did not follow the new guideline of SEBI, which is itself come from 2009. Number second is data pre-processing and cleaning. Before we moving the data pre-processing, let's us look at some basic terminology related to the mutual funds to understand it in a much better way. Some basic terminology. First point, NAV or net asset value. NAV of a mutual fund scheme is the price of prepaid unit by the investitor to the purchase unit of the scheme. Since the market value of the asset held in the scheme change every day, the NAV also change every day and it is disclosed by the fund on daily basis. It is important to know the NAV is the fund mainly to gauge the performance of the scheme over a period of time. It basically current market price of a unit. NAV is equal to market values of investment plus total expenses and minus liability divided by total number of unit with investitor. Number second point is sale price. The price of NAV a unit holder is changed while investing in an open-ended scheme is called sale price. It may be include sale entry load if applicable. Therefore, sale price is equal to net asset value plus entry load. But in year 2009, SEBI banned the entry of load for every mutual fund in India. Since there is no entry, that means sale price is equal to NAV. Repurchase price. Repurchase or redemption price is a price of NAV at which an open-ended scheme purchase or redeems its units from the unholder. From the unit holder. It may be include exit load if applicable. That's the repurchase price is equal to net asset value minus the exit hold. It's basically the price of at which AMC redeems the unit. And number fourth point is ISIN growth. ISIN is an abbreviation of International Security Identification Number. It is 12-digit alphabetic number. The first two letters of the ISIN code refer to the country in which the issuing company is based. The next nine and the next 9-digit identify specific security and act of unit identifier.
So now we will show our pre-processing. So we started by merging all the CSV files given for the entire 5 years and forming its combined data frame. So basically, we were given the day-wise data of different mutual funds from 2016, 1 January 2016 to 31st December 2020. So basically, we combined all the individual CSV files and formed a single data frame consisting of scheme code, scheme name, and net asset value, repurchase price, sale price, and date. After that, we dropped the column of ISIN division payout, growth, and reinvestment. So basically, we don't require this ISIN division payout column, repurchase price column, sale price column as discussed before, because sale price is basically the NAV if there is no entry load, and repurchase price is equals to NAV if there is no exit load. After dropping these columns, our data somewhat look like this, and after that, we sorted out our data frame via scheme code and its respective date, so that our data frame consisted of sorted values of schemes. After that, we formed a different data frame, aggregate data frame, by grouping scheme code in the original data frame and forming three new columns of representing minimum date, maximum date, and number of days. After that, we merged these three columns to our original data frame. So basically, our data frame looked like this. After that, we filtered the mutual funds on the basis of activity with a vintage of at least 1 year. That means considering only those funds whose daily NAV data is available for at least 365 days. That means our data frame should have only those schemes or those mutual funds whose number of days in the tenure of 5 years should be at least more than 365 days. So basically, we will, as you can see, Aditya Birla Sun Life Mutual Fund. Total number of days, the data of Aditya Birla Sun Life Fund is available for 1,232 days. But as we go down, we can also see some mutual funds. The data of some mutual funds is only available for 3 days. So basically, we will drop these rows so as to decrease the outlier. So basically, we filter the data on the basis of the number of days that should be greater than 365, and its maximum date should be greater than 1 January 2020, so that the funds segregated or filtered should be latest funds till date. should have latest. After that, we also deleted rows having missing or zero NAV values, and also computed per day percentage returns for each mutual fund. So here we can see that the code, this code, we dropped the rows having values as NAV or zero values of NAV. After that, we found a return which is represented here, which is nothing but the percentage change of NAV value, net asset value, on a particular day. After that, our data somewhat look like this, and I've shown here the return. Return is basically the formula for return is basically the current date NAV minus previous date NAV divided by previous NAV into 100. This will give our percentage return.
Now here we come in data visualization. Data visualization is the graphical representation of information in data. By using visual elements like charts, graphs, and maps, data visualization tools provides an accessible way to see and understand trends, outliers, and patterns in data. In this plot, now here you can see we have plotted the graph of net asset value with the count for each fund. For the scheme code is equal to 1000033. Same as that in the next graph. For example, we have plotted this graph for the return with the count for scheme code 134973. Now here we comes in data statistics. Statistical data analysis is a procedure of performing various statistical operations. It is a kind of quantitative research which seeks to quantify the data and typically applies some form of statistical analysis. The quantitative data basically involves descriptive data such as survey data and observation data. Now, in this data frame, now here you can see we have calculated the mean, standard deviation, minimum return, max return, and the median return for each fund. Now in this data, we have calculated the mean of the mean return of every fund. Same as that, we have calculated the mean of standard deviation of return of every fund, and same for all. Now we have arranged the return values in ascending order, mean return values in ascending order for each. Now, in ascending order for each fund with their mean return value, we have calculated the 25% position mean return. Same as that, we have calculated 50% position mean return, and same for 75% position of this mean return. Now here we come to prediction task. Here we will predict some mutual fund according to the different type of investors. For prediction, we will be using the method of Z-score. Prediction task. We will predict top 5 or 10 mutual funds selected by the different type of investors as mentioned in the below table. For different type of investors, for conservative investor, we should get low return, but should also have low risk. For moderate investor, we should get medium or high return, but risk should be low or medium. For aggressive investor, we should have high return, but risk should be, but there should be any risk for aggressive investor. The mean of mean return is 0.319% for a day, for example, bonus. But we look closely at 25, 50, and 75%, and the max of mean returns, like 75% of mean return is 0.0503%, but max is at 76.287%. This implies that there are some outliers. By shortlisting funds, we need to ensure that mean returns are approximately equal to median returns. To ensure that we do not have significant outliers, we need to consider that there are chances of data anomalies. And to be safe, it is better to consider this condition. Let us now rank mutual funds with the available data. That is mean return, median returns, the standard deviation of returns, mean, and max return. We need the methodology to compare mutual funds and random prediction task. Now here, we will approach by finding the Z-score for each one to find the top schemes favorable for the type of investor. We came up with an approach of using Z-score. Z-score can be computed by this formula. Z is equal to data point minus mean upon standard deviation. A ranking methodology using Z-score considers both the return component and risk component, where the return component is mean return and the risk component is standard deviation. This Z-score can also be further used in the hypothesis testing, where we will conduct a Z-test that whether the predicted mutual fund gives the target return or not.
Hypothesis testing. So for a conservative investor or a low risk investor, we have assumed our target return to be 0.01% per day. So with that, we calculated the Z scores with a given formula for the entire mutual funds in our data frame, and then we arranged them in ascending order and listed the top 5 mutual funds according to its Z score. And basically, these are the mutual funds suitable for the conservative investor as predicted by us according to the Z score. So one important factor to consider is that the mean return of the fund should be comparable to the median return of the fund. So if we see our mean return and the median return, which is approximately equal or near to each other, that means there in our data there is no outliers. After that, we also compared our findings with some external websites. One of the popular website is moneycontrol.com, and we found that our prediction was very much similar to their statistics. Next, we move to the moderate investor, that is the medium risk investor. And here we assumed our target return to be 0.04% per day. And then we calculated the Z score and listed the top 10 mutual funds according to the Z scores. But if you look the data very carefully, we discovered a problem here. That is the mean return for the top 4 funds is more than the expected return, but the median return of the is very poor. So let us see this. 4 mutual funds have a very good mean return, but the median return is not comparable, and therefore we can see that in these mutual funds there must be some outliers, and this is basically due to the insufficiency in the data, and therefore we should consider the next 5 funds which has comparable mean and median returns. After that, for the aggressive investor, we assumed our target return a little bit more, that is 0.1% per day, and again we listed the top 10 mutual funds according to the Z score. interesting thing to note here is the Z score of each and every mutual fund is always negative as predicted by us for the all the type of investors. After that, again we discover the same problem, that is the top four funds. The median return of the top four funds was very poor, as we can see here, and therefore we should again consider the next five funds which has comparable mean and median returns. So for the hypothesis testing, our hypothesis test will be to prove that the prediction of funds made by us for different investor is correct. So as we have already calculated the Z scores, we will use the Z test. So for the step one, our population is basically the per day return of a mutual fund from 2016 to 2020, and the distribution is a nearly normal distribution, as we can see in this graph, and the inferential test we used here is the Z test. After that, in step 2, the null and the alternate hypothesis for a conservative investor is as follows. That is, the H naught is the predicted mutual fund gives estimated returns that is more than 0.01% per day, and the alternate hypothesis is the predicted fund will not give the estimated returns. So as we have already the data of a mean return, standard deviation of the return, and the Z score, we will move to the next step, that is the critical values. So as this is a single tail test and we have assumed the level of significance to be 0.5, our critical value is 1.645, and the critical reason is more more than the 1.645. So basically, to reject the null hypothesis, the Z score should be more than the critical value, that is 1.645. But as we can see, the Z scores of all the predicted fund is negative, that is less than the critical value. So our final decision would be that we fail to reject the null hypothesis because of the insufficient evidence in the data. Similarly, we can show the hypothesis testing for all the predicted funds because all of them have negative Z score. All of them have a negative Z scores. Therefore, all of the funds predicted by us will always give the estimated returns.
How can we use this solution? We have ranked each mutual fund according to different types of investors. For the fund active during 2016 to 20, the same can be done for the entire data from 2006 21, and we can use recommendation of fund. One can into ranking and look for similar for betterment and make an informed decision considering accept return and risk appetite at the moment. Limitation of solution. We have used only one variable that is enabled to make the prediction. Real world problems are usually addressing by multiple variables. We do not address the ranking of fund across various types of levelization like large cap, mid cap, overnight fund, liquid fund. Use of an efficient machine learning model could have improved the prediction. Our teammate Aman Kumar, Jas Kumar Jha, Gaurav Kumar Meena, Rahul Kumar. Future plan: addressing the ranking of fund across various types for diversification like large cap, mid cap, overnight fund, liquid fund. Use any efficient machine learning to improve the prediction. Using some variable and increasing data frame.
So previously we actually calculated the top 5 or 10 mutual funds according to their Z scores for the different investors. So now we will look and observe these mutual funds predicted by us more precisely. So let us take one of the scheme mutual fund scheme via scheme code predicted by us, and we plotted the graph between the return versus date, and the graph somewhat look like this. And after that, we also plotted the graph of the same mutual fund net asset value versus date graph. So as we can see clearly that this graph is linear, and therefore we can use here a linear regression model to predict the net asset value of this particular mutual fund on a particular date, which is beyond this data frame. So basically, we used here the linear regression model for predicting the net asset value of a particular mutual fund, which is already predicted by us for different types of investor, but for a given time frame for a date which is beyond the given time frame. So we started with basically creating the data set for the model. So basically we have X data set and Y. Basically X contains the date of the date, and Y contains the particular corresponding net asset value of the mutual fund. After that, we splitted this data into training set and the testing set, and after that we fitted our training data into the linear regression model, and our model somewhat and after that we visualized our model prediction. As we can see, we plotted the graph between the prediction of the X training data. So here we can see we have the graph of net asset value versus date of the training set. After that we calculated and after that we plotted the graph of the net asset value versus date of the testing set as well. So after using the linear regression model, we also found some performance factors, which is basically the R2 score, R squared score, and the mean squared error. Also, we calculated the y-intercept and the slope of the linear regression model. After that, we can see the graph of our predicted line. And after that, using this, we made the table for the actual value of the net asset value of the mutual fund and the value of the mutual fund, net asset value of the mutual fund predicted by us. So as we can see in this table clearly that our predicted value is very much close to the actual value for all the entries. So therefore, our model was successfully made to predict the net asset value for the future dates. So similarly, we trained our linear regression model for different types of mutual funds, and as we have already predicted the mutual funds on the basis of Z score for different types of investors, we took that mutual funds and calculated its per year return for the future per year percentage return. And as we can see here, these were the scheme names of the mutual fund whose percentage return in 1 year has been predicted by us.